In this lesson, you're going to be introduced to positional parameters and the for loop. Here on my local system, I have a terminal open and I'm going to move into our class working folder. And from here into our Vagrant project folder, this project being local users. And then now I'm going to start the virtual machine and then connect to it. Now we'll move into the shared folder of cd/vagrant. And this script I'm going to name luser_demo06.sh. Of course, all scripts we start with a shebang, so we'll give the path to the bash interpreter. And then I'm just going to list the goal of this script or what this script does at the top here as our header. And the first thing we're going to do here is simply display what the user typed on the command line. And we can do that with the echo command here. The variable of $0 is actually a positional parameter, and positional parameters are variables that contain the contents of the command line. Before we go any further, let's talk about the definition of a parameter versus an argument. A parameter is a variable that is being used inside the shell script. An argument is the data passed into the shell script. So an argument supplied on the command line becomes the value stored in a parameter. With that in mind, the very first positional parameter is $0, which contains the name of the script itself. You can think of this as being what the person typed in the command line to execute the script. The next positional parameter is $1, which stores the value of the first argument passed to the script on the command line. The positional parameter $2 stores the second argument, $3 stores the third argument, and so on. So now let's look at the output of our script so far. Of course, we have to add executable permissions before we can execute our script. So we'll do chmod and then execute the script. So notice how $0 expanded to how we executed the script, this dot, / and then the script name. Now let's change how we call the script by providing the full path to the script. So we can type /vagrant luser_demo06 and hit enter. So again, when the script is called in an explicit way like this, then that is what is stored in $0. So $0 appears exactly as we have typed on the command line here. We're about to take a slight detour for a moment. Bear with me here because this will all tie into positional parameters, but again, it's going to take several minutes to explain this. So again, stick with me and be patient with me. So one thing I've glossed over is the command search path, which is stored in the environment variable path. That's PATH in all uppercase letters. Up until this point, we've just been supplying either a full or relative path to the scripts we've created. Let's take a quick look at what the bash man page has to say about the path variable before we move forward. Okay, we'll do a forward search with a / followed by path. We'll just keep hitting N until we get to the path variable. And here it is. It says that path is a separated list of directories in which the shell looks for commands. Now, if you were to look at the command execution section that it references here on your screen, you'll find that every time you type something in at the command line, bash first tries to find a function with that name and execute it. Now, we haven't covered functions yet, but don't worry, we will. So if it doesn't find a function with that name, it looks for that command in its list of built-in commands. If it is a shell built-in command, then it executes that. Now you've been working with several built-in commands such as echo, read, type, help, and so on. Now if the command you typed at the command prompt or on the command line is not a function or it's not a built-in, then bash searches through the list of directories defined in the path variable and executes the first match that it finds. If no match is found, then a command not found error message is displayed. So let's get out of the man page here by typing Q, and let's look at our path, echo $path. So in our particular case here, if a command is not a function or a shell built in, then bash will look for that command first in user local bin, then in user bin, then it will look in user local S bin, and so on down the list. It's important to point out that the path can be changed, so it's not something that is guaranteed to be the same for every user across every system. So keep that in mind. By the way, if you want to control the path, you can do so in your script by manipulating the path variable there. Let's use a neat little command called which to tell us which command will be executed. Let's take the head command that we've used before as an example. Which head. So this tells us that when we type in head at the command line, the program located at user bin head will be executed. The first directory in our path variable is actually user local bin, so let's create our own shell script named head and place it in there. We'll need root privileges to do that, so I'm going to create the file with sudo vim user local bin head, and then here we're just going to create a little shell script. Hello from my head. And then we'll go ahead and save it. We'll add the executable bit to it here. Now let's see which head will be executed. So we'll type in which head, and it says user local bin head will be executed. Let's use the -a option to which forces it to print all matching executables that are in our path. So there are the two commands named the exact same thing, both are named head, but the first one that is found is executed. So let's go ahead and just execute this command. Type in head and hit enter. Sure enough, our version of the head command is executed. Now if you want to override the default, then just supply the full path. So we can do that with user bin head. Let's say we just want the first line of the etc password file, so we'll execute that. So this is what we've been doing all along, which is explicitly defining a path to a command, or actually to our scripts. Let's get rid of the version of our head, so we'll just use sudo rm user local bin head. Here is one little quirk with rapidly adding and removing programs from your path. Bash uses a hash table to remember the full path names of executable files. It looks up the location to the executable once and then remembers it. If you look at the type head command, which we'll do here, type head, it says that head is hashed to user local bin head. That simply means that bash will execute that command at the path without first searching for that command. So here's the quirk. Bash thinks that head is still located at user local bin head. However, we just deleted it just a few seconds ago. So let's execute the command and see what happens. So if we type in head and hit enter, it says user local bin head no such file or directory. So if you run into this type of issue, you can make bash forget all these hashed locations by using the hash built in with hash -r. Now if we do type head, we can see that it searches the path and it finds the one that really is there in user bin. Of course, you can read about the hash shell built in with the command help hash. And there you can see the -r option that we use says to forget all remembered locations. Now, typically hashing is not a problem because commands don't usually just randomly appear and disappear during the same shell session, and probably not during the execution of a shell script. In any case, it's just something to be aware of. Okay, so I know that was a rather long aside, but let's bring this back around to positional parameters and specifically about $0. First, let's prove that our script is not in our current path. We can do that with a which command. Which luser demo06. And sure enough, there is no luser demo06 in our path, and it lists our path there, user local bin, user bin, and so on. Now let's take a copy of our script and place it into our path by putting it into user local bin. And we can do that with sudo cp for copy, and then provide the path to the directory we want to copy it to, and hit enter. Now our script is in our path, so we can execute it without supplying a path to the script. Now notice what's stored in $0. It's the full path to the command, which is user local bin luser-demo06.sh. Even though we only typed in luser-demo06.sh at the command line, bash found it in our path and executed it at that path. And that's why the path and the file is stored in $0. So let's review what gets stored in $0 in different situations. So we'll do ./luser_demo06. So ./ is what is executed, and that's what's in $0. If we're explicit again and provide a full path, such as /vagrant luser_demo06, that will be reported as well. However, if a command is in our path and we execute it, like so, then it reports the full path to that command. Okay, before we move on, let's remove the script out of our path before we continue. So we'll do sudo rm user local bin luser_demo06.sh. There's a command called base name that removes the directory component and just returns the file name. So let's read up about that command, man base name. Here at the top of your screen, you can see that base name strips out the directory and suffix from file names. So let's see what happens when we execute this. We'll just hit Q to get out of the help page there, and we'll type base name vagrant luser_demo06.sh, and then it just returns just the file name without the directory portion of the file. By the way, base name isn't doing any smart checking to see if the file exists. It just strips off the directory portion of a string that is passed to it. So we can give base name something that clearly doesn't exist, but it will still do its job. So we can do base name /not/here. And of course it reports here because that's the file name portion of that path to that file, even though the file doesn't exist. And we can prove that with ls not here. Sure enough, there's no such file or directory. The counterpart to the base name command is dir name. So let's look at the man page for that. This says that dir name strips the last component from the file name. Let's hit Q to exit out of the man page and execute the command. So we'll type dir name vagrant luser_demo06 and hit enter. And /vagrant is returned because that is the directory name or the directory portion of that full path. Like base name, dir name doesn't do any smart checking. We can give it a non-existent path and it will simply return the portion that looks like the directory. So we can do this, dir name, this is not here. Sure enough, it returns this is not because it looks like the here file is in the directory /this/is/not. But of course, that file and directory, that whole tree doesn't exist. But dir name doesn't check, it doesn't care. It just returns the path or the directory of the file. Again, obviously this works on things that do exist, but it doesn't matter to the dir name command or base name command. Now let's use these two commands in our script. So what we're going to do is display the path and file name of the script. In earlier lessons, you used a $ followed by a command that was wrapped in parentheses to assign the output of that command to a variable. That is called command substitution. In this case, we're only going to use the output of each of these commands once, so we just included them right in the echo command. Again, what this $parentheses syntax does, or this command substitution syntax does, is return the output of the command. You can assign the output to a variable or use that output without assigning it to a variable. Either way is fine. Perhaps assigning the output of the commands to a variable first makes for a bit cleaner code, but I just wanted to show you that you don't have to use command substitution and variable assignment only. You can use it in line as well. So let's save and execute our script and see what we get here. The first line says you executed this command, which is $0.0./luser-demo06.sh. You use dot as the path to the luser-demo06.sh script. So dot was the output of the dir name command, and luser-demo06.sh was the output of the base name command. So let's try executing this script in another way. We'll provide the full path, /vagrant luser-demo06.sh. So this time it lists /vagrant as the path, and then of course the base name of the script is luser-demo06.sh. Okay, let's look at the bash man page real quick. And we're looking for the special parameters section of the page here. And then we'll keep hitting N to continue to our next match. And then the thing I want to point out here is the pound sign. And the pound sign, it says expands to the number of positional parameters in decimal. So $pound sign tells us how many arguments were supplied on the command line. Let's continue with our script here. I'm going to use bang v to execute the most recent command that starts with a V, which is vim, so I can get back into my editor really quickly here. So let's tell the user how many arguments they passed in. Remember that the curly braces are optional, so some people might actually just use $#, so just be aware that if you're reading other people's scripts, but I'm going to use the curly braces here to be very clear. Of course, here you could have simply used the $#, directly in the echo command, similar to what we did with the command substitution in the previous echo command. It's really a style choice, and I just wanted to see how you can do it both ways. So the first time I didn't use a variable, this time I used a variable and then used the value of that variable in the echo command. So let's save our changes and then do some testing here. So we'll just execute our script. Says you supplied 0 arguments on the command line. So let's just type something in after the command line. We'll just type hello. And it says we supplied 1 argument on the command line. And we'll type in another word. You supplied 2 arguments and so on. So this one says you supplied 3. And that is giving us the proper information. So it looks like $#, works and we're all good there. So let's continue editing our script. Because the real goal of this little example shell script that we're working on is to generate a random password for each user that's supplied on the command line, we want to make sure that at least one user is supplied on the command line. So let's do a check with an if statement. So we'll use if space, double opening brackets, space. When we use a variable in between brackets here, we're going to enclose it in quotation marks. And the variable we're going to look at is number of parameters. And then we want to make sure that that's -LT, which stands for less than 1. So if the number of parameters is less than 1, then what we're going to do is echo a usage statement, much like you would see in a man page. Instead of manually typing in the name of the script, we can just simply use $0 to echo back more or less what the user typed in at the command line. And then we'll tell them what they need to do. They need to supply a username. And optionally, they can supply another username. And actually, optionally, they can supply even more usernames. So we'll use the ellipsis there. Now, if they get to this point, that means that the script did not successfully execute because they didn't give us any people to create passwords for. So what we're going to do is exit with a non-zero exit status. And I'm just going to use 1 here. Close our if statement with fi. Now, by the way, let's look at the first line here again. If the number of parameters is less than 1, then blah, blah, blah. So here, what I'm actually doing is just demonstrating something that we haven't used before, just a slight variation of -LT. And where did I get that from? Well, hopefully you remember that you can get help on these tests by looking at help test at the command line. Of course, you'll find in there that -LT stands for less than. Of course, what is the only thing that's less than 1 in our particular situation, working with whole numbers here on the command line? Negative numbers don't make sense because you can't supply negative arguments and this sorts of thing. So obviously the only thing that's less than 1 is 0. So you could have said if the number of parameters equals 0, then give them the usage statement and exit. So again, either way is right. It's just your personal preference, how you think, what makes sense to you. It's style. Again, both ways work. Just whatever comes to mind, just use that. Again, I'm using this here so you can see some slight variations in different ways to do this. Now let's save our changes and start passing in varying number of arguments to our script. We'll hit enter. We did not use any arguments on the command line, and we get our usage statement. And if we check the return code with $? Or you can actually do this, $? With curly braces, then sure enough, we get an exit status of 1 from our script since it didn't successfully execute all the way. So let's get back to our script and let's just give it one thing. Sure enough, you supplied 1 argument, 2, let's do A, B, C, D. Okay, that's 4 arguments. And I want to point out something here that we used actually with the user add command in an earlier script, which is enclosing things in quotation marks. So A, B, C, D. So this says that you supplied 3 arguments on the command line, but maybe at first glance you think that B and C are 2 different things, but in reality, because they're enclosed in quotation marks, they're treated as 1 argument. Let's do this again. Let's do this 1. This whole thing is 2, and here is 3. So again, in this instance, we supplied 3 arguments on the command line. Another thing you can do is simply enclose everything in quotation marks, and that's fine as well. I'm just going to use single quotation marks because that works too. We'll do 1, this is 2, and this is 3. So again, 3 arguments on the command line, which interprets to 3 positional parameters inside the script. There are 3 because they are enclosed in quotes, so it doesn't split at spaces when the data passed in is enclosed in quotation marks. Now, again, the idea behind this script is that we're going to perform the same action over a list of items. Now, this is the perfect time to use a for loop. Let's take a second and look at the for shell built in. The type-a command says for is a shell keyword, so that's a shell built in, and so what we can do is get help for. I know there's going to be a good bit of information that pipes out to the screen, so I'm just going to pipe this to the head command to get just the first 10 lines of output. Okay, the first line of the help says for name and words, do commands, done. The name you see in the help here is actually a variable name. For each item in the list of words, the variable name is set to that item, then the commands are executed and the process is repeated for each item in the list. Let's create a loop right here at the command prompt. We'll do for x, x is the name or our variable name, and we're going to provide a list. We'll do this, Frank, Claire, and Doug. The next thing we want to do is type in do, hit enter, and then it's stylistically appropriate to indent, so I'll just put a couple of spaces here, echo, type hi, and then refer to the variable name here, $x, and hit enter, and close our for loop with done. In this example, x is first assigned to Frank, then the command of echo gets executed using that variable $x. Then the next time the loop repeats, Claire is assigned to x, the commands execute, and finally Doug is assigned to x and the commands execute. If I hit the up arrow here to pull up the command, you can see the semicolons which represent the command separators. So if you want to, you can place this command all on one line, but it's easier to read if you do not do that. Again, it's valid syntax here, like you see at the help for on your screen, but again, it's just easier to read if you put these on multiple lines. You want to hit enter again to execute that again. If you look near the top of your screen in the help output for the for keyword, it says if in words is not present, then $@ is assumed. So let's find out what $@ is by looking at the bash man page. I'm going to look for the special parameters here in the man page. Here's the section. Now let's start with the @ special parameter. It expands to the positional parameters starting from 1. When the expansion occurs within double quotes, each parameter expands to a separate word. That is, $@ is equivalent to $1, $2, and so on. Now, this is nearly the same as $**. It also expands to the positional parameter starting from 1. However, if it's enclosed in double quotes, it expands to a single word. We don't want to treat all the parameters as a single word. What we want is a list of words as they were supplied on the command line. That's why we're going to use $@ and not $* in our script. By the way, the use of $* and $@ are often confused. Okay, let's get out of the man page here with Q and get back to editing our script. So we're going to use a for loop. We'll do for, we'll supply a variable name. We'll call these usernames, user_name, and we'll use quotations here, $@ do. So we're going to use the command we used to generate passwords in the previous script. So we'll do that with password equals. We'll use command substitution with $ followed by an opening parentheses. And then we're going to display that username and password. Now, obviously, we can't know exactly how many positional parameters a user will attempt to supply at the command line. We can check for them, but we just don't know in advance. So instead of, generating a password for $1, $2, $3, and so on, even though they may only supply 2 arguments, for example, then what we're going to do is use $@. So no matter how many arguments they pass into the script, it is covered by $@, so we don't have to guess what the user is going to do. They can supply 1, 2, 3, or 10 or more, and this script is going to work just fine. We'll just supply one thing on the command line to see what happens. So sure enough, the for loop executed one time, generated a password, and displayed it for the user. Let's add another user on the command line. Let's add some more actually. So by using the for loop in conjunction with $@, and we were able to account for everything passed in on the command line. Just for demonstration purposes, I want to show you what the difference is between $@ and $**. So let's just go back into our script and make that change. So here I'm going to change the @ to an asterisk, save our changes, and then execute our script again. So as you can see, it treated everything on the command line as one argument. So the for loop only ran one time and generated a password for that one argument. Again, that's the difference between $* and $@. Let's go back and fix our script here and change this asterisk to the @ symbol here. Save our changes and check our script. And sure enough, it runs like we want it to. Let's take just a minute to recap this lesson. And by the way, we covered a lot here. First, you learned about positional parameters and how $0 expands to the name of the shell script, and $1 expands to the first argument supplied on the command line, $2 expands to the second argument, and so on. You also learned a few different special positional parameters, such as $, which represents the number of parameters, $**, which expands to the list of positional parameters starting at $1, and $@, which also expands to the list of positional parameters starting at $1. However, the difference between $* and $@ is only noticed when enclosing them in quotation marks. That difference is that $* treats all the positional parameters as one string, and $@ treats them as separate words. We also took a slight detour in the middle of the lesson to talk about how the path shell variable is used to store a list of colon-separated directories that make up the command search path. You also saw how the path variable can affect what commands get executed and why that is. Along the way, you were introduced to the which command as well as the base name and dir name commands. Finally, you learned how to create a for loop, both at the command line as well as in a script.